Glyza Barrios from the Bachelor of Secondary Education, major in General Science. Now, I am going to recall or share you guys about what I have learned from the videos I've watched earlier about the gas law and the second law of thermodynamics. Now, I have learned that to apply gas laws, we need to identify the changing variables, which is the pressure, volume, temperature, or even the amount, and use the corresponding formula of the Boyle's law, Charles' law, Avogadro's law, and even the Gay's Lossachs. So in the Boyle's law, there is the P1 times V1 is equal to P2 times V2. In the Charles' law, there is a V1 times pi over T1 is equal to V2 over T2. In the Avogadro's law, there is a V2 over N1 is equal to V2 over N2. In the Gay-Lossachs, P1 over T1 is equal to P2 over T2. For ideal gas law, there is a general formula which is the PV is equal to nRT. Now, I will be going to share you guys about how to use the ideal gas law, or which is the PV is equal to nRT. Now, I have steps here. So, step 1, you need to identify known values or identify the given values or the number of moles, temperature, and either the pressure or the volume. Step 2, you need to plug in values. Plug these values and the gas constant, which is the R, into the equation to solve for the unknown values. Now, to rearrange the chemistry equations, you need to isolate the desired variable by performing inverse operations. You need to multiply or divide both sides by the same value, and then add or subtract the same value or from both sides or cancel out the common factors. So to ensuring the equation, you need to it remains balanced. So when the solving is right, that means it is balanced. Now, to give you more knowledge about the gas laws and second law of thermodynamics, gas laws and thermodynamics, I gained that comprehensive insights into gas laws and the second law of thermodynamics, principles and the fundamental principles of governing chemical and physical interactions. There are K of gas laws, which is the Boyle's law, Charles' law, and Avogadro's principle. Now let's talk about the Boyle's law. When we say Boyle's law, it is the pressure to volume, inverse relationship of the pressure and the volume. When we say Charles' law, or let's talk about the Charles' law, it is the volume to temperature. It is a direct relationship of the volume and the temperature. When we talk about the Avogadro's principle, it is an equal volumes of gases contain equal molecules. Now, let's talk about the second law of thermodynamics, or the states that entropy, or the disorder or randomness, always increases or the overtime in isolated systems, meaning heat energy cannot spontaneously transfer from a colder body to a hotter body, and energy conversions are never 100% efficient. The laws of thermodynamics govern energy interactions, with entropy or the disorder increasing over time, while Gibbs free energy or the change in Gibbs free is equal to change in heat or the temperature change in is or the product's reaction of spontaneity. In the second law of thermodynamics, there is an entropy increase. That means that the systems tend towards disorder and randomness. The second is reversible and irreversible process. That means that the energy transformations and directionality. The third is the thermodynamic system equilibrium. That means that the balance between system and the surroundings. So there are applications and implications of the second law of thermodynamics, which is the ideal gas law behavior, or the ideal gas behavior. That means that the predicting gas properties, the thermodynamic cycles, efficiency and energy conversions, and also the chemical equilibrium. That means that the reaction, direction, and spontaneity In the second law of thermodynamics, there is also a biological systems. That means that the energy metabolism and organisms functions. There is a practical significance. That means that the engine efficiency. It is an optimizing energy and conversion. In the refrigeration, there is a cooling systems. And also in the chemical synthesis, there is a reaction optimization. And when we talk about the environmental science, it is the climate modeling and energy balance. So this knowledge enhances my understanding of molecular interactions, energy transformations, and chemical reactions, providing a solid foundations for further exploration in chemistry, physics, and related fields. So that's all my understanding or what I have learned from the videos that I've watched. And that's all. Thank you.